Our topic of today is motion of two masses connected with each other via string, and the string passes over pulley. Okay, and one of the mass goes down and the other goes up. The situation is similar, is shown in this video. You can see that the two masses are connected via string, and the string passes over a pulley. Mass m1 is moving down and mass m2 is moving in the upward direction. Okay, so we are talking about this kind of motion. Over here, in my case, the mass on the right side is heavier. Okay, I change its color so that you can identify it. This is mass P, okay, which is of 0.7 kg. Okay, this is mass P, which is going down. Okay, and over here it has touched the ground. And this mass P, I've shown the whole side of P uh, red. Okay, okay, this is it. Now you can see that mass P has a mass P has is of 0.7 kg and mass Q is of 0.5 kg. Mass P will go down, will accelerate down, and will mass Q will accelerate up. Okay, since they are connected by a string, and that string slips over pulley without friction, they have same acceleration and same velocity at any time. And the distance moved by P in the downward direction, distance moved by P in the downward direction is equivalent to the distance moved by Q in upward direction. And you know that their initial height was 0.6 meter. So as P went down by 0.6 meter, Q went up by 0.6 meter. So the total distance that Q moved in upward direction is 1.2 meter. Okay. When P touches the ground, the string becomes slack. There is no tension in the string, but Q doesn't stop over here. It continues to move up in because of its inertia. And this becomes the stage 2 of the motion of Q. Okay. So the motion of Q consists of two stages. One is moving up a distance of 0.6 meter. In that stage, Q was accelerating in the upward direction. Its velocity was increasing. Its velocity was increasing, okay, like this. And its velocity was maximum when it traveled a distance of 0.6 kg. And then when P touched the ground, Q didn't stop over here at the height of 1.2 meter. It continued to move up. Okay, and it's the second stage of its motion. We will call it motion due to inertia. In this motion, the tension in the string was 0 and acceleration was equal to minus 10 meter per second square. And after that, when it reached at its highest point, it came down and stopped over here. And the whole system was resting in the situation shown in the rightmost diagram. Okay, so we will now apply Newton's second law of motion and our equations of motion to do some calculations and know more about it. But let me tell the assumptions that we take while conducting this kind of calculation, while doing this calculation. Our first assumption is that string is inextensible. The string which is connecting, or the thread which is connecting the both masses is inextensible. Inextensible string, okay? And the second is string slips over pulley without friction. Without friction, okay? And no zero resistive forces or air resistance. Zero resistive forces. Okay. Now let us see what kind of forces are acting on both. Okay. In the case of P, the mass P, the weight is 7 Newton in the downward direction. I've calculated it by applying the formula of mg. 0.7 kg into 10, I get 7 Newton. And the tension of the string is acting in the upward direction. The forces are shown with the purple color. Its weight, the weight of Q is 5 Newton, and the tension T is acting in the upward direction. Now, if P accelerates in the downward direction, Q will accelerate in the upward direction. Q will accelerate in the upward direction. And if P accelerates in the downward direction, it means that T is less than 7 Newton. And if Q accelerates in the upward direction, it means 5 Newton is less than T. And if I combine these two, I can say that 5 Newton is less than T and T is less than 7 Newton. Or you can say that the tension will always be in the middle. The tension will always adjust itself somewhere in the middle of the two weights. Okay. Tension will always adjust itself in the somewhere in the middle of the two weights. Okay. So the tension over here, the value of tension is somewhere in the middle of 5 and 7 Newton. It may not be exactly 6. It will not be exactly 6. It might be different from that because the two masses are different, having same acceleration. So driving force for them are different. Okay. Now applying Newton's second law of motion on 7 Newton, on 0.7 kg on P, 7 minus T is equal to 0.7a. Okay, we call this acceleration as A1. And then applying Newton's second law of motion on Q, it's T minus 5 is equal to 0.5a1. Both have same acceleration as they are connected by an inextensible string. And then adding these two equations, we get 2 Newton is equal to 1.2 A1. And A1 is equal to 2 over 1.2. What is the value of A1? Please tell me the answer. Please tell me the answer.
0.6.
20 over 12, 10 over 6,
Or
5 over 6, 1.67 meter per second square. Okay. So this is the acceleration 1. P will accelerate down with this value. Q will accelerate up with this value. And P travels a distance of 0.6 meter with this acceleration. So what is the final velocity with which P touches the ground using this value of acceleration? Final speed square minus initial speed square, 1.67, and distance is 0.6 meter. Can you calculate this value of V is equal to under root 2 into 1.67 into 0.6? What is the value of this? What is the value of this velocity?
1.42.
1.42. Okay. And what time it took to reach the ground? What is the time that taken by P? What is the time taken by P? Acceleration is equal to 1.67. So what is the time taken by P?
0.85.
0.85 seconds. Okay. Now, when P reaches the ground, when P touches the ground, the tension becomes a 0. Okay. Q was at a height of 1.2 meter. You know, it was already at a height of 0.6 meter and it went up another 0.6 meter. So now its in height is 1.2 meter. It doesn't come to rest instantly. It doesn't come to rest instantly. It's in stage 1, its velocity was increasing like this. And in the stage 2, its velocity will start decreasing, coming to rest, okay, at the topmost point. In the stage 2, we call this distance as S2, and the acceleration in this stage is minus 10 meter per second square. And we call this motion as motion due to inertia. Okay, so A2 is equal to minus 10 meter per second square. A2 is minus 10 meter per second square. The final velocity of previous motion is now the initial velocity of this motion. The final velocity of this motion is 0. And S2 is equal to what? You can use this formula. 2as is equal to v square minus u square. And s is equal to v square minus u square over 2a. And 0 square minus 1.42 square over 2. And acceleration is equal to minus 10. What is the answer of this value? What is the answer of this calculation? Yes,
0.1.
0 point,
1.
only 0.1?
0.10082.
Okay, 0.1, we call it 0.1 meter. Okay. We call this distance as S2, okay? And the time T2, V minus U over final speed is 0, initial is 1.42, acceleration is minus 10. So it's 0.142 seconds. Okay. And the total height gained by Q is Q is 1.2 plus this 0.1 meter, 1.3. Okay, so the total height of Q is equal to 1.3 meter. Do you understand this thing?
Yes.
Okay.